This is a very simple program using the core timer interrupt and demonstrating the 7 steps to use an interrupt that we discussed earlier. All this program does is toggle one of the lights on the NU32 on or off every second. And the way it does this is it uses this counter value, 40 million here, and we know that the core timer counts 40 million times per second. So when we reach 40 million, we're going to toggle the light and just do that in an interrupt routine. So here's the syntax for the interrupt service routine. We can see over here the double underscore ISR syntax, which says that this function is an interrupt service routine. It's type void because it doesn't return any value. And it takes 2 arguments. The first one is the vector of the interrupt and the priority level. So the vector here, we use a constant core timer vector that's defined in our P32MX giant file that we looked at earlier. All it does is it defines the core timer vector constant to be 0. So we could have equally just said 0 here instead of writing out that constant. This other choice here was the interrupt priority level. We're using priority level 7 with the shadow register set. If we wanted to use some other priority level, we could have used IPLN soft. And this would say we're using interrupt priority level N, where N is 1 through 7. Soft means software context save and restore. In this program, we're going to use the shadow register set. OK, so the name of this function is core timer ISR. We could have called it whatever we want. And the first thing that we do is we clear the IRQ flag, the interrupt flag. And we do that by clearing the appropriate bit in the IFS0 special function register. In the next step, we just toggle the light. And then here, we're going to set the timer value of the core timer back to 0. And this last step is saying, generate another interrupt when you get to 40 million again. And that's all the interrupt service routine does. Now down here in the main function, we do our normal startup. And then this is step 2. We're going to disable the interrupts at the CPU. So now the CPU will not respond to any interrupt requests. At the next step here in step 3, we configure the device, in this case the core timer, to generate an interrupt whenever it reaches the value of 40 million. The next 2 steps here, or next step is step 4, broken into 2 lines of code, where we're setting the priority and the sub-priority. So we're manipulating the IPC0 special function register, in particular the core timer interrupt priority bits, setting it to 7, and then the core timer interrupt sub-priority bits, setting to 0. The next step is step 5 right here, and that's where we're setting the interrupt flag status to 0. So we're going to make sure that no interrupt has been requested when we start back up. And step 6 here is to set the interrupt enable bit in IEC0. So now this interrupt source can start generating IRQs. And finally, the last step here is step 7, and all it does is re-enable interrupts to be processed by the CPU. And now we're ready. So anytime we reach 40 million in our core timer count, we're going to jump up to here, set the core timer back to 0, and reset the core timer to interrupt again at 40 million. And that's it. All we do down here is we enter an infinite loop in this while loop, and the program does nothing but sit there and wait for the core timer to hit 40 million, and then it goes up and toggles the light.